The next part of the lesson, all the subsequent questions are the important one. Alright? The first few, I'll make use of 3 diagrams first. Let's take a look at what is given. There are 12 thermometers. 4 are 40. What's the opposite of 40? You can say not non-40 or you can say working condition. So how many of them are in working condition? 8. So I write down first. 8. I can also say 8 are good. Can I say that? Alright? 8 are good. 4 are 40. Alright? Next. A customer select 2 thermometers. One after another. If you take 1 thermometer away, how many thermometers are there? Huh? There are 12 thermometers. You take 1 away, you still got 7, man. Okay? So this is the case of cannot be replaced. You remember at the start, a lot of things are replaceable. But when you're buying stuff, are you going to replace? You take 1 already, you cannot replace already. Unless you don't want it. Okay, so how do we represent such? Okay, I'm going to show you. I'll denote the good ones by G. I'll denote the 40 ones by F. Can? How many outcomes are there? Either good or 40. Am I right? There are only 2 outcomes. But how many thermometers are we buying? How many thermometers are we buying? 2. So, what is the heading? First thermometer. Followed by second thermometer. Okay, I'm drawing bigger. How many outcomes for the first thermometer? How many outcomes, Soshen? Outcomes. How many possible ways I can get my thermometer? No. How many branches do I draw? The thermometer either good or 40 what? So how many outcomes? 2. Either or yeah lah. Good. 40. Okay. Now it's unlike other question. Each of the branch I must fill in the probability. Okay. What's the probability I'll get a good thermometer? 8 over 12. Let me write down. 8 over 12. But please don't just write down 8 over 12. You need to reduce to lowest term. What is it? 2/3. So what's the probability that the first thermometer will be 40? What would it be? 1/3. Don't write down 1/3. I'll tell you why later. Please write down 4 over 12 first. And this is equal to 1/3. You'll be asking, teacher, why you so nitty-gritty? Why must write the original one before you reduce to lowest term? I'm going to explain in the second branch. So the first branch all settled already, right? First thermometer. Okay? Now I pause for a while. Okay, so like I say, alright? Please write the original number so you know the total number of thermometers. Don't just write the simplified one. Okay, I'm going to do next branch. Same thing. I'll have either it to be good or 40. Now look carefully. I'm going to zoom in. A, 1 good thermometer is taken away out of the 8. How many good thermometers are there left? 7. Am I right? So I need to write down 7. Is it over 12? Is it over 12? Over 11 because there's always 1 thermometer taken out. 7 over 11. That's the probability that the second thermometer will be good. Then, what will be the probability the second thermometer will be 40? Have I taken out any 40 ones? Not yet, right? So there are still 4. Out of how many? 11. Okay, I'm going to tell you right now. Every branch will always sum up to 1. We learned that previously. Can you see this one will sum up to 1? Likewise, this one must sum up to number 1. Am I right? Because that's the total possible ones. Okay, can you draw the last branch yourself? So I'm going to solve the question now. They want us both thermometers are 40. If you trace the path, this is the only one. Alright? It's unlike previously, I measure by the outcomes. So, very simple. I want both thermometer to be 40. Okay, it's the highlighted one. So, what is the first path? 1/3. Alright? It must be 40 and it must still be 40. Alright? This is an AND case. Both must happen at the same time. So you need to multiply as you do the path. No need to press calculator lah, Adrian. No need to press, can see one. Okay? Now, I want you to try part B yourself. In the previous question, the probability that both thermometers are 40 and 40. Am I right? Okay, it can be presented this way, but you don't have to write. But I'm going to write the second one. The probability that one of the thermometer is 40. What are the cases possible? Am I right to say, if the first one is 40, the second one must be good? Is this the only one? That's another case, right? It can be a case of, if the first one is good, the second one must be 40. These are two different steps. Alright? Within the same branch, the same path, you have to multiply. But if you have to do two different branches, you have to add them together. Alright? So I'm going to show you the path. 40 followed by good. So I have a 41 followed by a good one. What is this path? 1/3 times 8 over 11. So I write down 1/3 times 8 over 11. I have a second path. Good followed by 40. Good followed by 40. Good is 2/3. So I write down 2/3. Multiply by 40, which is 4 over 11. Then your job is very simple. Whatever you have in the bracket, please sum them up and press the calculator. Okay, can you please do that for me now? Alright, press the calculator carefully so you can see that the tree diagram will make use of your question. But I want you to take note, please write down the branches in its original number. Don't reduce to lowest term only. Alright?